You know, concrete. It's kind of this silent giant that's all around us, right? It's literally holding up our entire world. But what happens when that giant gets sick? What if there's a fatal flaw growing deep inside, totally hidden from view? Well, today, we're going to dive into the incredible tech that actually lets us see the invisible.
I mean, just look at these massive structures. They feel so permanent, almost invincible, don't they? We trust them with our lives every single day. But here's the thing. That trust, it hangs entirely on their internal integrity. So the real billion-dollar question is, how do we know they're not quietly failing from the inside out?
Because that is the real danger, you know? The biggest threats to concrete, they're not always the ones you can spot with your own eyes. We're talking about things like microscopic cracks, hidden voids that were left over from when it was built, or even this slow, creeping cancer of chemical corrosion that's attacking the steel skeleton on the inside.
And that brings us to the heart of the problem. I mean, you can't just take a jackhammer to a bridge support column to check if it's holding up, right? So how do you give a health checkup to a patient you can't cut open? How do you find a tiny flaw without making it a massive problem?
Well, the answer is just brilliant, and it has a name: non-destructive testing. Seriously, this is where engineering gets a little bit of, like, superhero magic.
Okay, so let's break this down. NDT, or non-destructive testing, it's basically a whole family of techniques for checking out materials and structures without breaking them. That X-ray vision analogy? It's absolutely perfect. It's all about peering deep inside solid concrete to see what's really going on, checking its health, its strength, all of it.
So, what does this X-ray vision actually look like in the real world? Come on, let's open up the Engineer's Toolkit and take a look at a few of the most common and, honestly, most clever methods they use. All right, first up, we've got something called the rebound hammer. You might also hear it called a Schmidt hammer. Think of this as the quickest, simplest checkup you can do. It's not going to see super deep inside, but it gives you an instant reading of how hard and uniform the concrete is right there on the surface.
And how it works is incredibly simple. You just clean the spot you want to test, press the hammer firmly against it, and thwack. A little spring-loaded mass inside hits the concrete and bounces back. The tool measures how far it rebounds. You do that a few times in one area, average the numbers, and bam, you've got your reading.
And the results? Super straightforward. It's pretty simple. A higher rebound number means you've got harder, better quality concrete. So, if you get a reading over 40, you're looking at a really good, strong surface. But if that number drops below 20, well, that's a big red flag that the concrete is probably in poor shape. It's simple, but really effective.
Okay, let's move on to our next tool, which is definitely a step up in tech. This is the ultrasonic pulse velocity test, or UPV for short. Now, if the rebound hammer was just a quick surface check, think of this one more like a medical ultrasound. We're literally using sound waves to see what's going on deep inside the concrete.
So here's how it works. An engineer places two little gadgets called transducers on the concrete. One of them is a transmitter, that's the T, and it sends out a pulse of high-frequency sound. The other one is a receiver, the R, and its job is to catch that pulse on the other side. The machine's whole job is to measure with incredible precision how long it took for that sound to make the trip.
And here's the key takeaway. Sound travels way faster through solid, dense stuff. So a velocity over, say, 4 kilometers per second, that tells you the concrete is in excellent shape. But, and this is the cool part, if that sound wave hits a crack or a void or some crumbling material, it has to go around it, which slows it down. So if you get a reading below 3 kilometers per second, yeah, that tells the engineer something's not right on the inside.
All right, our third tool is a bit different. This one isn't about physical strength, it's about chemical health. It's called the carbonation test. See, healthy concrete is supposed to be highly alkaline, and that alkalinity creates this amazing protective shield around the steel rebar inside, stopping it from rusting. But over the years, carbon dioxide from the air can seep in and neutralize that protection. That whole process, it's called carbonation.
So how do you check for this? Well, an engineer exposes a fresh surface of the concrete and just sprays it with a special chemical indicator. And the result? It's instant and it's all visual. If the concrete turns this bright pink or purple color, awesome. That means the pH is still high and the steel inside is protected. But if it stays colorless, that's bad news. It means the concrete is carbonated, that protective shield is gone, and the steel is now in danger of rusting away.
Okay, so we've looked at a few of these cool tools, but let's zoom out a bit and connect this back to the real world. Why does any of this matter so much?
Well, it really boils down to 4 huge things. First, and this is the big one, is safety. It's all about finding a problem before it leads to a total failure. It's also way more cost-effective, right? You can catch a small issue before it turns into a multi-million-dollar repair job. It's fast, so crews can check out massive structures in no time. And finally, it gives you hard data, so the people in charge can make smart, informed decisions instead of just guessing. And you'd be amazed at where this stuff is used. We're talking about the bridges you drive over every single day, the foundations of skyscrapers, tunnels, even in places like nuclear power plants where, let's be honest, failure is just not an option. You could say NDT is like the unseen guardian of our entire modern world.
Now, this technology is already amazing as it is, but believe me, it is not standing still. So let's take a quick peek into the future and see where all of this is headed.
Really, the future is all about making our infrastructure smart. So, instead of doing checks every now and then, imagine this: embedding tiny, advanced sensors directly into the concrete when it's built. These things could measure strain, tilt, vibration, you name it. And they'd all be talking to each other and to the cloud, using the Internet of Things to create a live, 24/7 health report for the entire structure.
So what does that actually mean? Well, for one, AI will be able to analyze all that data, making inspections way faster and more accurate than a human ever could. We'll have robots and drones going into dangerous or hard-to-reach places to do the testing for us. But the real game changer? It's predictive analytics. By looking at all this data over time, we can stop just finding failures and start predicting them long before they even have a chance to start.
And in the end, that's really what this is all about, isn't it? Concrete might seem like just silent, inanimate stuff, but it's actually telling us a story all the time. A story written in stress and strain and chemistry. Non-destructive testing is what gives us the power to read that story, to understand its warnings, and to make sure we act before the final chapter becomes a tragedy.